Our development process started with the fundamental question: can we predict a fire before it starts? One way to do this is through multispectral imaging, which is a primary cost driver for modern competitor drones. We quickly discovered that terrain flammability is often inconsistent and patchy. Relying on just two raw variables was insufficient to account for the complex environmental factors that influence fire risk, such as time of day, terrain type, and ambient humidity. To overcome these hurdles, we pivoted to a multivariable architecture. We expanded our dataset across diverse locations to ensure environmental variability and supplemented our infrared camera with standard digital photography. This allowed us to capture dual stream data, a thermal infrared image paired with a corresponding RGB photo. We collected a dataset of 200 dual image pairs, physically sampling soil moisture at 5 specific spatial points within each frame. This resulted in 1,000 calibrated data points, providing the high density information necessary to transform a hit or miss experiment into a reliable, predictable tool. To process this data, we developed a sophisticated multimodal data fusion pipeline using the PyTorch framework. We modified a ResNet 18 deep learning architecture to accept a custom 4-channel input tensor. This allowed our model to simultaneously process normalized long-wave infrared data along with the 3-channel RGB vegetation cues from the dual camera input. While infrared images emphasize the relative heat distribution, the RGB data provides critical surface, texture, and vegetation health cues. We also incorporated ambient temperature as a normalization parameter, allowing the AI to distinguish between true ground level heat abnormalities and false positives caused by time of day or weather conditions. This multivariable approach solved the patchiness of our earlier models, creating a seamless understanding of fire risk. FireFlight moves beyond just a simple unsafe and safe classifications. We implemented a linear regression final layer to predict a continuous risk map. By training our model using the mean squared error loss and an 80-20 validation split, our system can operate with a 90% accuracy rate in evaluating relative dryness. During inference, we utilized a sliding window technique with a stride of only 8 pixels. This model compares incoming visual and thermal data against learned moisture temperature relationships to generate a high-resolution dryness index overlay. This identifies ignition-prone zones long before a spark can occur. By grounding our AI in physically measured data and rigorous validation, we have turned reactive firefighting into proactive land management. Our momentum began with a major milestone when we were named the Oklahoma State winners for the Samsung Solve for Tomorrow competition, providing us with $12,000 in technology that has been instrumental to building our AI infrastructure. We then moved from the lab to the field, working with Fire Chief Brian O'Neill to ensure our platform is tactfully useful to the people who actually wear the gear. This work earned recognition from the Oklahoma Secretary of Commerce, who identified our project as a vital resource for the state. This relationship provides a pathway towards state grants and scaling operations necessary to protect our regional resources. Finally, our commitment to affordability to solve environmental problems led us to UPenn Warren's EcoVenture Challenge. Securing first place in an international competition from renowned faculty, we got the ultimate layer of credibility and funding required to advance our design to the national stage. President Trump's commitment to addressing this crisis is evident through the Farmer Bridge Assistance Act. By providing vital relief funding to farmers in Oklahoma and across the country, this legislation demonstrates the unified national investment in the recovery and resilience. Through the Presidential AI Challenge, we aim to leverage the expertise of industry leaders like Amazon and collaborate with the federal government to scale our solution nationwide. Our objective is to further validate our AI's credibility and secure the funding necessary for advanced prototypes that safeguard our community's most valuable resources. Together, we can turn preventative data into local action.